If you take a number, let's say 13, divide it by 2 and note the remainder. Do this repeatedly until it becomes 0 and then read the remainders in reverse order. You get the binary equivalent of 13. This is the decimal to binary conversion algorithm. We all know it, we all trust it, we all memorize it. But if you really think about it, why divide by 2? Why do the remainders matter? And why does reversing them gives the answer? Well, today we are going to answer all these questions. So let's jump, not from the roof, but into the video. Let's forget this algorithm for a moment. Instead, let's imagine an alien, a very stubborn alien. He knows only three things: addition, multiplication, and how number systems work. And by knowing number systems, I mean just one thing: place values. That is, in decimal, every digit represents a power of 10. For example, 123 could be written as 1 into 10 raised to power 2 plus 2 into 10 raised to power 1 plus 3 into 10 raised to power 0. And in binary number system, 1101 could be written as 1 into 2 raised to power 3 plus 1 into 2 raised to power 2 plus 0 into 2 raised to power 1 plus 1 into 2 raised to power 0. That's it. He refuses to learn anything else. No division, no remainders, no tricks. So here's the challenge. Can he convert the decimal number 13 into binary using only these three tools? Let's see. The alien accepts the challenge and starts working on it. He observes that the binary form of any number is simply a string of zeros and ones, like this. So 13 must also be written as a string of zeros and ones. He assigns a variable to each digit. Hence, he writes this, where each variable a, b, c, d, and e can only be either 0 or 1. Notice that it's truncated towards the left because the number of binary digits isn't known beforehand. So he assumes infinitely many digits extending to the left. Now, using the concept of place values that he already knows, he writes this equation. If he could solve this equation, he would know the value of every variable and hence the binary conversion of 13 as well. But the equation has infinitely many variables, so it isn't straightforward to solve. Then the alien comes up with an idea. He splits 13 into this, and then splits 6 into this, and keeps doing the same all the way down. Now he starts substituting. First, he substitutes the value of 1 from here to here and simplifies it. Then he substitutes the value of 3 from here to here and simplifies again. Repeating the same process all the way to the top gives him this expression. Now this expression looks familiar. It's exactly the same form as the equation we wrote earlier for 13. By comparing the two equations, he immediately gets the values of a, b, c, d, and e, while every remaining variable to the left is simply 0. And just like that, he has found the binary form of 13. And yeah, 13 has been converted to binary without ever thinking about division or remainders. Now, if you trace where these digits come from, the value of E comes from here, the value of D comes from here, and the value of C comes from here, and so on. If you take a closer look at the original equations, you will notice that A, B, C, D, and E are nothing but the remainders obtained while dividing by 2. You will also notice that the leftmost bit comes from the last equation, which is exactly the remainder obtained in the last step of the original algorithm. That's why the remainders have to be read in reverse. And as for why the number is divided by 2, that should be quite obvious by now. And that's the complete reasoning behind the divide by 2 algorithm for binary conversion. If you found this video helpful and want to watch more videos like this, do subscribe to the channel.